My name is Carlos Santana. I'm a CNCF ambassador. That's a volunteer position. If you want to learn more about being a CNCF ambassador, check with me or any other CNCF ambassador here that we are hearing this week, and we can tell you about the program. I also have to make a living, so I work in AWS as a solutions architect for the EKS service. That means Kubernetes using AWS. And today's talk is on the novice track on explaining how Kubernetes works with GPUs. Who's here because they searched the word GPU on the schedule? And you show up. OK. So that strategy worked. Who here has a home lab of trying to install Kubernetes at home? OK. So maybe at the end of this talk, everybody will raise their hand. This talk is an introduction of a story about running Kubernetes at home. And some of the basics are applicable running GPUs workloads on the cloud. But for this, people are new to Kubernetes, or maybe like myself, I thought I was an expert on Kubernetes. I was doing this at home. So let's start with the scenario. So the scenario is that I want to learn at home. I want to learn with machines or computers, old computers that I have at home, about Linux, for example, and then Kubernetes. There's some sound coming from the other side. It's kind of annoying. So we start, what's the recipe? So you get yourself maybe a 5-year Kubernetes expert. So we're talking about 5-year expert. And then you combine that. So that's for me, for example, have worked with Kubernetes since 2016 in another cloud provider. Now I work for AWS, working with EKS for the last 3 years. So I taught myself that I know Kubernetes enough to get Kubernetes running at home. So at home, I have different devices, and my wife hates that I bring or buy another cable in my house. Who has that problem? So she asked me, why do you need another cable? Well, because I might need it at some point, right? But in this case, I have all these little devices. So I have things that run Linux. I have Esperinos. I have Raspberry Pis, I have NUCs, I have old laptops, I have laptops that don't have a screen, and I try to learn and just boot up Linux and boot Kubernetes. But with the late trending of LLMs and ChatGPT, running GPUs just for playing around or learning on the cloud or from a vendor is kind of quite expensive if you don't know what you're doing. So in that case, I thought myself, well, let's get myself a GPU at home. And a lot of people actually have game machines. Who have game machines at home that have a GPU card PCI? So a lot of you. So you already have that. I got one of these. I also bought a Turing Pi that you can put accelerators, chips that are accelerators. You can use some AI there. But I wanted to use the one that a lot of our customers that I work with are using in the cloud, and that's NVIDIA GPU. So I bought an NVIDIA Jetson device, and there's these small computers that you have at home, or actually these devices are development kits that companies use for manufacturing edge devices, and they come with a system-on-chip GPU. So that's the recipe. So what's the project? You always have to have a project. So if I have a Jetson GPU, what do you think will be my LLM project? Rosie, who knows this character? It's from the Jetson family, right? It was supposed to be a joke there somewhere. So Rosie is very smart, right? So I want to create a bot. I want to play with LLMs. I want to play with these frameworks, Python frameworks like PyTorch, Ollama, all these open source LLMs at home. So let's start off when you search online or you ask these AI search agents of how do I start with, and maybe you want to get started, usually it's just do a Helm install. I tried that, it didn't work. So I wanted to learn what are the components of Kubernetes or the minimum things to get Kubernetes working with my GPU that is sitting on my desk. So I thought about doing this talk in terms of how I did my learning and doing this. And in Amazon, we have a leadership principle called learn and be curious. You always have to be learning and be curious. So I really wanted to know what is the integration between GPUs and Kubernetes. I know Kubernetes, I can figure that out, but I didn't know what was the integration between GPUs and Kubernetes. So we start with something like the node feature discovery, which is something that will go deep into it. But basically, that this is the things that you do. But I wanted to know, like, but why? Why do I need the node feature discovery? Why do I need the GPU feature discovery? Like, why do I need it? Do I really need it to run a container in Kubernetes to use the GPU? Actually, no. The other one is device plugin, also another component that you install in your Kubernetes cluster. But I want to know, like, well, how does it work, right? The why and the how. So on this talk, we'll see a lot of those. And then the next thing is a vendor, right? A vendor will give you a device driver. That's the next step that you need, that you would install in Linux, and you have to watch out which version do you get for that device driver. The next one is container toolkit, which is related to things like Docker or Containerd or the Kubernetes runtime. And the last one that some people have confusions is CUDA. And for these folks, they may ask, like, CUDA, is that a game or that's a cookie? Or like, what's the deal with CUDA? Where people get stuck when they're trying to do GPUs in Kubernetes. And this tag is applicable on the cloud. It doesn't matter if it's at home or it's in the cloud. So the benefit that you get at home is that you start learning about how to work with them and understand how they work. So let's start with the breakdown. So the main three areas to get this working is the host, the operating system in the worker node, which you will have to deal with the device driver container toolkit. And that's something that you don't have to install because you are working with a cloud provider. The cloud provider usually gives you a OS image that comes with this already out of the box. And a lot of people get stuck because they go ahead and install a different version that is not compatible on top of it. The next one is CUDA. And the CUDA is a toolkit from a vendor. I'll try to make this agnostic as possible, but in this case, we're talking about NVIDIA, which is a very popular vendor of GPUs. So the container toolkit is something that is a shim on top of, for example, Containerd or Docker with run C to be able to, this container runtime, to be able to handle the GPU integration with the device driver. And the last one is where Kubernetes come into play. But the first two, you have to figure that out for the operating system in your worker node. And the last one is, what are the things that we put on top with Kubernetes to help with the scheduling of these pods on the nodes? The next one, so the first one we're going to take a look is the device driver. So the device driver is divided in two parts. Is the part that you install in Linux to talk to your hardware. So that driver comes from the vendor that you get for the specific chip that you're using. So for example, using AMD chips, you will get the device driver for that. If you're using NVIDIA, you will get the NVIDIA driver that comes with the CUDA user mode driver. So that's where CUDA starts coming into play, that you need the driver and CUDA combination correctly. So for Jetson, if you get the Jetson Nano or Jetson Orin, one of these Jetson boards, it's a Jetpack OS. And that Jetpack OS actually comes with a specific device driver that comes with the right version of CUDA that you don't have to install on top of it. If you're working on a game PC, like I asked before, that you're just installing, for example, an operating system like Ubuntu, for example, and you have a game card on the PCI slot, you may need to get that driver and install it. And for those type of things, you can actually use there's an operator that comes from NVIDIA, but that operator usually is complex, but if you know what you're doing, then you can go ahead and use it. I tend to, for this talk, to concentrate on like the building blocks to understand how it works. So the next one is the CUDA toolkit. So the CUDA toolkit is something that interacts with the driver, but something that you can bring inside your container image. So you will have to pick a library, and usually the libraries that you use, like PyTorch, OLlama, llama.cpp, VLLM, all of them already have CUDA support, and they have a specific version of CUDA that is the interface to talk to that device driver. So that they always go together, that compatibility layer. You need to be aware, and this is where a lot of people get stuck of like, why is this not working? And it could be that you have a device driver that is not compatible with the CUDA toolkit version that you have in your container image that came from an open source project, right, or a vendor. So usually we recommend in production, get one from the vendor. In open source, get the right version from open source that has the one that works with your environment. So what's that relationship? So one of the things that you can check, the device driver is this command here. You can go into proc driver NVIDIA version and get the version of the device driver that you have in your operating system. And that's something that you can need to start with. You don't want to start changing the device driver to the latest to see if you can get the best features. Just get the one that comes with the operating system. That could be on the cloud, or it could be from the Jetson Jetpack. And then the next one is, how do I know which CUDA version do I have on the operating system? I will get into a minute into that. This is specific if you are using the GPU driver from the host operating system, not from a container. If it's in the host operating system, then you can have the toolkit, or if you are compiling an application to then package it, to then include it in the container, you have to watch out about the CUDA version. And the last two versions are CUDA 11, CUDA 12. So here's like one example of the table. You can go online and actually see the compatibility matrix of like device driver to CUDA version, depending on the operating system that you have, for example. So let's start with the container toolkit, going deeper on how these actually work. So the container toolkit is something that you install in the operating system, or you can install it with a daemon set, for example. A lot of these things that you work in the operating system usually are done through a pod that has privileged access to the node so that you can change the configuration of that containerd or Docker. So in that case, when you install the container toolkit, it has a runtime library. Then you configure it saying Docker at a runtime. So in this case, it will be the NVIDIA runtime, or containerd at the runtime NVIDIA, and you can set it to default. This is a shim that NVIDIA has that then talks to runc. When runc runs, basically what it's doing is, hey, I'm going to run runc, but there's a hook that it will call an NVIDIA program here that we see in the screen, that it would inject the information about the GPUs when the container gets started. So runc would create the container, not started yet, and in this webhook, its ability to change the configuration or modify the configuration of the container before it starts, so it can have access to the devices, like the GPU in this case. So that's why you need the container toolkit, to be able to enable, in this case, containerd that Kubernetes is going to use the GPUs, to access the GPUs in runc. So with these three, actually you can get started using containers on your Jetson device without the need of Kubernetes. And that's basically the first test that you would do. If this doesn't work, then there's no point of going beyond this to get Kubernetes working. Because if it doesn't work, it means that you have the wrong device driver, or you don't have the right CUDA toolkit, or maybe the image of the container that you're going to run in Kubernetes, it doesn't have the library. So you have to test, in this case, at that layer. And then, again, you can do this at home for learning. So at this level, if you have a Jetson board, Jetson Nano, Jetson Orin, there's multiple Jetson. There's a new one that came out recently, but there's a great GitHub, I would say a community around these devices. We have a Discord, but this GitHub repo, I have the links at the end. You can run on the Jetson probably any LLM or any machine learning or any AI framework, library, model out there, just from this repo. So it's amazing what these folks have done in this GitHub repo, that they have a build system and they have the library. So they made it super, super simple to get it running. So let's take an example of one of the things that you can do at home. So if you have a camera at home and you have a Jetson, you can use one of the packages in here to detect things inside your house or inside the manufacturing, things that maybe don't need that data, doesn't have to go out to a cloud, or because of latency or GDPR, or just because it's at home. I want to play around with things around my house, like IoT devices, like sensors on my doors, sensors at the front door, video cameras to be able to detect things and and learn about it. So at this point, you're learning at home with these devices with a, again, like an old game PC or one of these Jetson that I got or any other ones. But the basics are there. Once you have the device driver, the toolkit, you'll be able to do this with Docker. So basically Docker or containerd using like cry or cryctl, you pass -- runtime. Basically that will tell the Docker or containerd, when you run this container, run the NVIDIA runtime that has that hook that it would insert the device driver information as environment variables, for example, which GPU you're going to use. In this case, the Jetson only has one GPU, but it's something that you can test any library that is out there. So let's move on. And here's an example on a little CLI utility that this GitHub repo provides you. It's a Jetson containers. So this is a wrapper around Docker. So basically, this is an example of running Olama, or in Spanish, I call it like Ojama. So basically, you run name Olama. The name is the package from the GitHub repo that you want to run. And then auto tag Ojama, basically that's a command to get the right version of CUDA that is detected. So that's why it's important to get the right image for your hardware, because you need to get the one that has the specific CUDA that is compatible with your device driver. And again, if you have a specific, you could have a version of the device driver that can work with CUDA 11 or CUDA 12. So a lot of this software detects which driver do you have and which CUDA to use, but basically to get the right image. So in this case, I'm doing a small test of saying how many Kubernetes administrators takes to deploy a cluster. So it depends on the experience of the administrator. The model says it's from 2 to 3 administrators to deploy a cluster. So it depends what is the complexity of this cluster. But again, LLMs will give you an answer based on what they were trained on. The next one is the Kubernetes device plugin is required. So this is where we start. Like if everything works in your computer, in the computer with Docker and Docker runtime, then the next layer is the device plugin. And why do we need the device plugin? In this case, I can install Kubernetes, get a pod deploy, and that pod will start using the GPU. If I deploy another pod, we'll start using the GPU. If I deploy another pod, we're using that GPU. So there's no scheduling, there's no allocation, there's no resource management. At this point, the pod can run with the runtime, and then the GPU will work. So at this point, you can install Kubernetes and it will work. But you're missing the scheduling, and then all pods have access to all GPUs, so there's no way to allocate this GPU to be used by this pod, this other GPU to use by these 2 pods, without then the next layer of tools. So let's start with the GPU device plugin. And when you read online that people say install the Helm package of the device plugin, and then this will be the device plugin by a vendor. So in this case, we're talking the NVIDIA Helm package for the device plugin is a combination of 3 components. It's the device plugin itself. It has a second component called the GPU feature detection, which is, I'll get that into a minute. And the third one is a Kubernetes open source SIG. It's the non-vendor specific, but it's included as a subchart, which is the node feature discovery. This would allow you, the device plugin, now the capability to schedule pods. So not all pods access all GPUs, or you can have pods waiting until one completes, and then it gets a slot to use the GPUs at the maximal throughput or the advantage of taking everything. And then things like share a GPU with time slicing, MPS, or MIG. In Jetson, it's a small device, system on chip, so not all these features will be supported on the Jetson. For example, MIG is something that is hardware specific, so it will not be in the Jetson. But time slicing with 1 GPU or 2 GPUs you can do. So that's why you need the GPU package. So like we started at the beginning, the professor telling someone just install the big Helm package you can use, but you can just install the device plugin, or it can come with the operator. So let's break this down. So the first thing of this component that runs on your cluster, the other two are not running. So when you do Helm install of this package, they don't get installed. So the first one is the node feature discovery that will actually read the PCI information, GPUs, and be able to detect that there's a PCI component that is the GPU, like you can see here. The next one is the GPU discovery. So once the device is available, this GPU feature discovery is specific to NVIDIA. So we will query the device driver to know what information about the GPU that I can get, and then annotate the nodes. So these two things annotate with, they label the nodes with the features. So these are how the labels get into your worker node to know that from all the worker nodes, this one has a GPU and information. And then the last one is the device plugin that is a component that works with the kubelet. So they interact with the kubelet to allocate the devices. So you can say, it will tell you how many GPUs are available, or if you're going to split a single GPU into time slicing, it can say 4 pods, 4 containers can use 1 GPU. So the integration with this is the device plugin, when it starts, is it registers with the kubelet. Then the kubelet asks, like, how many GPUs do you have? The device plugin gets back that number. So it could be 4 GPUs, and the Jetson will be like 1 GPU. And then that information gets into the API server by the kubelet saying, these are the GPUs that you can allocate, for example. And then when there's a pod requesting a GPU, then the kubelet comes back to the device plugin saying, allocate GPU 0 or allocate GPU 1. Kubelet goes back to the API server and says, a GPU is allocated. Maybe you have 4 from the 4 that you started. Now you have 3. When you start the container, the kubelet start the container, it knows that it needs to start the container with the NVIDIA runtime if that's the default. If not, you can put it into the pod spec. So that's the integration between device plugin. So let's see it in action. So if you have like a set of GPUs and all the pods are running and taking 1 GPU, then you don't have space for the other pods, so they're pending. So for example, you can have a workload of all this work or jobs, for example, a queue of pods trying to use the GPU. So now you have the device plugin, and now you can use Kubernetes to orchestrate, basically, right, the pods in this node. I only have 1 node, so they will go pending. If you have things like Carpenter, for example, it will see these pods that are pending, that are requesting a GPU, or Carpenter or any autoscaler that works like that. It would create a node, for example, in the cloud that has a GPU, and then that pod goes there. So in this case, at home, I don't have more than 1 Jetson. So when the pod gets completed, then the allocation is available, and the pod goes in, and then it starts running. So this is the benefit of using the device plugin. But before, I was able to run the pod and use the GPU. So the why and how. So for running containers on the host, you need the device driver, container toolkit, and CUDA. To orchestrate containers, now you need the device plugin and the feature detection. And the feature detection is very valuable because it would label the nodes. The first one, the node feature detection, is an upstream Kubernetes SIG that detects the PCI devices and actually is looking in a folder in the host operating system for labels that any other agent can put in there, and then the node feature discovery will start creating CRs for another container called the master, is the one that labels in the API server. So the GPU feature detection, discovery, it will detect the information about the GPU, like the NVIDIA, the vendor, the CUDA, the device driver, all that information, put that in a folder in the host, and then the node feature discovery will detect somebody put something in that folder, which is in etc specific place, and then the node feature discovery is the one labeling. So the GPU feature discovery doesn't need RBAC access to the API server, never talks to the API server. Device plugin never talks to the API server, and then node feature discovery is the one that talks to the API server, so it needs RBAC. So if you're starting with Kubernetes, it's always a good practice to inspect the Helm charts, the packages, or what do they install, what permissions do they need, which component needs RBAC. So coming to an end, this is an example of my home lab. I have a bunch of devices. So the first one is
where do I run the control plane? Where do I run API server and the etcd database? So in this example, I have an Intel NUC, and I have a Jetson or ring with the GPU. And all of them at my house, I have a big 24-port switch. But then I run the API server in another NUC inside my house. So everything runs inside my house. And you can run out of the box K3s. If you put K3s -- runtime NVIDIA, we'll do the setup for containerd. And basically, that's the enough after you install the device driver and CUDA. And then it's installing the Helm chart with the device plugin. You can use kubeadm. I tested that. All these notes I have in my GitHub repo, so if you want to replicate it. And any other Kubernetes flavor or distribution, K0s, you name it. Everything works as long as you have the device driver, CUDA, and then you install the Helm chart. And then the second setup is something that I do at work, because I help a lot of customers and end users trying to run Kubernetes in manufacturing at edge, but they want the control plane to live in the cloud. So this is a setup for AWS specifically, where you have EKS hybrid nodes, that the nodes itself run on my house, and the only thing that I need in my house is the kubelet, the containerd, the NVIDIA device driver, CUDA, and toolkit, and then connect them with a VPN. For example, WireGuard is a very popular open source project. You could use WireGuard with VPN, connect to the cloud, but the control plane is the normal EKS cluster that you have in the cloud. Just nodes would just show up that I put a label called home. So if I want something to run at home, I just schedule that pod to run on the nodes that are labeled home. So they run on my devices. So in this case, the Turing Pi is a cool device that has 4 slots that you can put Raspberry Pi modules. You can put an R1 module. And then I have an Intel NUC, a bunch. They're very cheap, less than $100 in some of those used markets. You can get it to build something at home that is very affordable to start playing with Kubernetes. So here's the demo on the setup. This is running DeepSeek R1 on the Jetson Kubernetes cluster at home. For the Jetson, you would not use a utility called NVIDIA SMI because on the Jetson, the GPU doesn't run on a PCI device. So there's another utility called JTOP, and it will give you the GPU usage. So as you can see here, you can see the GPU pegged to 100%. You can also change how much watts do you allocate to the device so you can get more power out of the GPU. And then this is Olama with the Open Web UI, and one of the many frameworks in that GitHub repo that I show. But this is running DeepSeek R1, and I think the question here was, I don't see it. It was, tell me 5 jokes I can give at KubeCon next week during my talk. So it started thinking, and it took a while thinking, and eventually came with the 5 jokes. If you can see me after the talk, I can show you the ones that it came up with, and some of them were not proper, so I'm not going to show them. And then DeepSeek, one thing that I want to emphasize, and this is a novice track, is all these models, they will run on these small devices. Take into account that there's a process called quantize, that it will the resolution of the numbers are smaller. So you can have the model quantize that actually will fit a small device. But when you run on the cloud, you actually run on a beefier machine, GPUs, so you will run the full model at the full potential. And it could be one of the many models, and you will hear many models this week for that. So coming to an end, this is the GitHub repo KX NVIDIA. I created this a while back ago because I also run a Kubernetes book club out of the CNCF. It's a community group. We get together every Friday, so you can join virtually or you can watch the videos. And basically, we pick a book, and we discuss the book about Kubernetes, platform engineering. I think I did one on Jetson devices. We talk all things Kubernetes as a community book club. You can find all the information here, even running Knative, serverless containers with Olama in there. Thank you so much. Complete the survey, and if you want to talk to me, I'll be around all week. On the AWS booth, I'll be around there. So thank you so much.